Hello there. Atoms to computers, an introduction. How exactly do we get to computers from atoms and electrons? Introduction. This is an introduction to a series of lessons in which we'll build an understanding of fundamentals of physics, mathematics, and chemistry that make electronics and computing possible. The goal of these lessons is for us to understand and give a narration of exactly what is happening on an atomic scale in electronic circuits that enable them to operate the way they do. We'll also develop an understanding of scientific principles and mathematical definitions that are relevant to electronics. We'll then leverage this fundamental understanding to build our knowledge base towards more complex aspects of electronics. The eventual goal is to give an account of how computers operate from fundamental maths and science, or in other words, how we tricked rocks into thinking. Why this series exists. The reason I am undertaking this series of lectures stems from a realization I had after completing my undergraduate studies in engineering. Even though I acquired knowledge in advanced topics of electronics, I realized that I didn't have as good of an understanding of how basic physics and chemistry led to electronic circuits and eventually computers. Particularly, I had a poor understanding of exactly what is going on with electrons and electric fields in wires and electronic components that compels these devices to behave in a manner that allows us to exploit them for power and logical systems. This series of lectures aims to address this basic understanding. Learning in the age of AI. I hold a somewhat contrarian belief that in a world of large language models, having a good foundational understanding is now of increased importance. I believe it is better to be adept at reasoning from fundamentals rather than being a subject matter expert in an advanced domain. This is because large language models consume vastly more quantities of information about a subject than a human could in 1,000 lifetimes. It is impossible to outread AI, but I am quite sure it can be outreasoned. Course structure. So what will we cover in these lessons? We'll begin with atomic structure and the nature of charge. We'll then progress through electric and magnetic fields and how they interact with matter. We'll then move on to current, voltage, and resistance at an atomic level. Then we'll cover basic components and their physical operations before covering semiconductor physics and how we engineer materials to control electron flow. And eventually, we'll cover digital logic and how we create computational systems. I'll make available the full course content documents once I have completed it. Please subscribe to my YouTube channel, and sign up for my Substack newsletter to be informed when I make these things available. I'm actually reading from my Substack newsletter. Okay. The resources and materials. The primary texts I'm using for this series are Practical Electronics for Inventors by Paul Skirres and Michael Monk, and The Art of Electronics by Paul Horowitz and Winfred Hill. This video will come with accompanying notes and practical exercises. See the video description for more details. And to sign up for my newsletter to receive accompanying materials including problem sets that will help cement these concepts. Looking ahead, the next upload I will post will begin our journey into the world of math, science, and electronics. We'll start from the very beginning, the structure of atoms and the nature of electric charge. If that sounds interesting to you, feel free to follow along. Cheers.